Hello and welcome to day 14 of Advent of Code 2023. As you can see, I have already solved the puzzle, so let's go see the puzzle and my solution around that. Now in this puzzle we have a platform, which is our puzzle input, which is like this, and it consists of three different characters. Either it's an empty space, which is represented by a dot, or a hashtag, which means it's a cube-shaped rock, or it's a O, which means that it's a rounded rock. And there is a control panel that can tilt the platform to the north, east, west, or south. In part 1, we only tilt the platform to the north. And when that happens, all the cubic shaped rocks stay at the same spot. But all the O-shaped rocks or the rounded rocks will roll to the north. So for example, this one will roll to the north. And they will continue rolling to the north until they get either to the edge of the platform, or they get to another O, or they get to another cube-shaped rock. So for example, in this puzzle, this O will be rolled to here, and this O will be rolled to here. And for example, this row will be rolled up to here, this will be rolled to here, and this will roll all the way up to here. Now we need to do some calculation. And the calculation is like this, that we index them from top to bottom, 10 to 1 in this example, and all the O's will be weight to the amount of the index that they have. So for example, this one is 10, this one is 10, and all of them are 10. So the weight here is 1, 2, 3, 4, 5, 15. For this one we have 2, 9. For here we have 4, 8, and all the way to the done. And then we add all these values together. So how can we solve this? Let's go to the code. So here in part 1, make it a little bit bigger. So at first I would, as always, map the input to a 2x2 grid. After that this happens, we would go for each row and then for each column, going from 0 to the length, and then for the columns we go from 0 to the length of that row, and then we check that row. Either it's a O or not. If it's not a O, which means it's a solid rock, or it's a dot, we just skip it. And if that's a O, then we need to check all the slots above that. So here, for example, let's go to here. So for example, if we are at this state, we need to check all of these for I from here up to here. If we get to a O or a hashtag, then we stop. Otherwise, we go to the up. So in this case, this will never happen, because from this index up to here, I cannot see any hashtags or any O's, so this will never happen, and I would get to here, which means that from this index up to here there is no rock. What would happen? This O will go here and this will be dot. So here I would replace these two values and I would break out of the for loop. And if I get to a hashtag or an O, so for example, let me find an example here. So for example here, for this one, I would go to here, it's a dot, go here, a dot, go here, it's a O. So I have gone 3 steps. The current index will be dot, because this has been rolled up, so this will be dot, and this will be an O, which has done here. And then I need to break. I don't need to check all the positions above this index that we found. And that's basically it. And just for adding, we just do 2 for loops, and if that's a O, we would add the value of that by the length of the array minus y, which is obviously, so from here to here is 10, and if we are, for example, here, we need to say 10 minus 1, which is 9, and we would add the 9 for this one. So this is basically for part 1, pretty straightforward. So let's go to part 2. We can find a button that is labeled spin skill, and this spin skill will do the tilting in 4 different ways, one after each other. So it will tilt to the north, then to the west, then to the south, and then to the east. And then we need to do this for this amount of cycles. So obviously we don't need to have a for loop that calculates everything, so we need to find the solution around this, because this is a huge number. And this is basically finding a pattern in the previous ones. So what do I mean by that? So let's go here. So for example, let's suppose that this is iteration 1, and we need to go like 1 billion times. After iteration 1, we get to some grid. We keep this in a map. Then we go to point 2, we get another grid, keep that in map, and continue going forward. And in each step, I would check this grid against the map and see if I have already seen that one or not. So for example, we go to like 75, and when I get the 75 grid, I would see that this grid is already happening on, for example, let's say 25. So this grid is the same grid as this one. What does this mean? This means that after 50 steps, starting from 25, I will always get the same grid. So I can say this and then go 50 steps ahead each time until I get to, for example, a point like here. Now, the thing is that I have already come this far, but I can skip from here to here because the state that we have here is the same thing as we have here. But what is this index? Well, this is pretty straightforward. So we have come 25 steps and the length that we want to skip is like 50, 75 minus 25. So I get this number, which is 1 billion, subtracting from 25 to get this chunk. And I would divide this by 50 and get the remainder. So from here to here, I would divide this chunk by 50 and get the remainder, which would be this much. So for example, this can be, this is 5, let's say 15. What does this 15 means? It means that from here I need to go 15 steps, which is the same as going from here 15 steps or from here 15 steps. So when I get to an index that I can see a repeated pattern before that, I would calculate this value and then from here I would do the for loop for this much and I would get to here, and this value is the same as this value, or the grid that I get here is the same as the grid that I get here. So we already have been solving this for 90 times instead of 1 billion times. Then I would calculate the sum for this state. Let's go to part 2. I would get the data the same way as part 1. Then I would create a grid map, which is a new map, and then I would go from 0 to this value. And every time I will circle the grid. This is basically just tilting it to the north, to the west, to the south, and to the east. And the tilting is basically the same thing that we have. So the direction north is the same as the for loop that we have here. So for north, for south is just doing the same thing but going to the south. And the same goes for the west or east. I won't go into the details for this one. There are just 4 different if with the same logic. And when I get the cycle, I will add this to the grid. And the merging is like this. I would just add this value together to get a very huge string. And I would check to see that if that hash that I already created is in the grid or not. If it's in the grid, we need to do the calculation as shown here. If it's not, we just add this to the hash and then say this has happened on that index that we are currently in, so that we could later on go to this index. And if we find a matching hash or matching grid, so to say, to do this calculation, get the origin of the hash, which will give us this number 25. Then we get the length, which is from here to here. Then we get the remaining, which is going from here to here, which means this much. And then we get the mod of that remaining, which means that we need to divide this by this value and get the remainder, which is this much. And then we would do the cycle for that much values. And when this is done, we do the calculation as we did in part 1, the same thing, and get the sum, and we would need to break that because we don't want to continue this huge for loop. And yeah, that's basically it for part 2. So yeah, that was basically about it for this puzzle. I hope you've enjoyed the video. If that's the case, please provide a like, comment, and subscribe to my channel. That would really help me in growing my channel. And as always, code is in the GitHub channel. So thank you for watching and see you in the next video.